Hello everyone, I'm Tung. Now I'm going to present the paper, Shielding Applications from an Untrusted Cloud with Haven. The authors are Andrew, Marcus, and Galen from Microsoft Research. Different from local and private environment, when using cloud services, there are many security problems that needs to take into account. In particular, adversaries may come from the network interface, and there might be malware running on the cloud as well. It can compromise the provider's platform and interfere with the user's virtual machines. So the goal of this paper is to propose and develop a system called Haven, which can achieve completely secure private execution of unmodified applications, such as SQL Server and Apache, in an untrusted cloud on commodity hardware. Intel SGX is the hardware that is used to build the system. The motivation underlying Haven comes from the fact that when using cloud platforms, there needs to have a huge trusted computing base, including privileged software such as hypervisor firmware, management software stack of the provider, people who may have access to hardware, like the provider staff. They can be system administrators, cleaners, or security guards. And lastly, law enforcement bodies may reach and replicate data. The hierarchical model of the cloud system also leads to the hierarchy of trust, and any layer at the bottom of the stack can observe or modify any data at layers above them on the stack, even if data is encrypted before storing or sending over the network. When data is decrypted to compute, it is vulnerable to compromise. About current approaches, the first one is hardware security modules. These are dedicated crypto appliances. They are fairly expensive and just offer a limited set of APIs for storing keys and performing crypto operations, such as signing, encryption, and decryption. The second approach is to use a very small secure hypervisor or microkernel environment. However, it still requires system administrators to be trusted, and the applications may still suffer from physical attacks such as memory snooping. More importantly, the machine is trusted to run the expected trusted hypervisor. Another approach is a mechanism called remote attestation. The idea is that through time, we construct a secret hash of all privileged software running on the machine, which is then signed by a small piece of hardware like TPM chip. Then the remote user can check the hash and the signature to decide to trust that remote machine. However, the user needs to trust the current hash value sent by the cloud provider is correct. So the security guarantee that people would like to achieve is equivalent to the setting where a user operating on his own hardware in a locked rack at a colocation facility. The cloud provider is responsible for offering power, cooling, network access, and nothing else. Providers can be malicious. They can turn off the power and perform attacks via network interface, but cannot access data inside the machine. So that's the definition of shielded execution. Basically, the idea is to protect a specific program from everything else in the system, regardless of how privileged it is. The programs that are aimed to be protected are unmodified existing applications. The program is protected both in confidentiality and integrity, all of its intermediate steps, control flows, register values, etc. If this can be done correctly, the program can compute on encrypted inputs and produce encrypted outputs, and no intermediate steps and all the data that it operates on will remain confidential. The host can deny service, it can choose not to execute the program, or limit the resources that it gives to the program. But if the program produces outputs, it cannot alter behavior of the program. In general, the threat model of Haven is an actively malicious cloud provider where nothing except the CPU is trusted. All the provider's software is assumed to be malicious, and all the hardware beyond the CPU is untrusted. Haven does not take into account denial of service attacks, as well as does not handle side channel attacks. Haven is built on hardware named Intel SGX. SGX is an extension architecture for isolated execution. It allows an application to construct a region of its virtual address space, known as an enclave. The application can put secrets and code that operates on those secrets into the enclave. The hardware ensures that nothing else on the system can interfere with or corrupt operations in the enclave. SGX also includes a remote attestation mechanism so that the remote user can verify that the exact and expected software is running inside the enclave. At the hardware level, an enclave occupies a contiguous region of virtual address space, and pages that make up the enclave are backed by a specific region of hardware encrypted and integrity-protected physical memory. The hardware also ensures that the OS cannot interfere with the page table mappings underneath the application. Now, I'm going to talk about two design challenges to execute an unmodified application in the enclave. The first one is Jaguar attacks. An application depends upon an operating system and assumes that the operating system is correct. The application interacts with the operating system through system calls. And these system calls provide the perfect way for privileged malware to corrupt the behavior of the application. An example of Jaguar attacks is system calls may return semantically incorrect results and exploit latent bugs in the application. The proposed approach is to admit all the OS functionalities that the application depends upon into the application's trusted computing base. The second challenge is that binary applications load code and data at runtime, dynamically allocate and change protection on virtual memory, raise and handle exceptions such as page faults, divide by zero, or floating point exceptions. Haven addresses these by emulating unsupported instructions and carefully validating and handling exceptions that occur within the enclave. In Haven, a picker process is constructed, which is an isolated user mode address space. Inside picker process, an enclave is constructed, and inside the enclave, unmodified binaries are loaded, which depend on Windows API provided by Library OS. Library OS is essentially a subset of Windows, which is integrated to run in process with the application. And the shield module implements typical kernel functionalities, such as scheduling, file system, thread synchronization, etc. It also includes an untrusted interface with the host OS. The untrusted interface is a key interface at the enclave boundary responsible for ensuring mutual distrust. This interface is designed with the idea of policy and mechanism separation. In Haven, the guest controls all policies over virtual resources for example, virtual address pages, threads, etc., while the host still controls all policies over physical resources, for example, physical pages, visible time, etc. The untrusted interface consists of about 20 calls with fairly restricted semantics, as you can see in the figure here. On top of the untrusted interface is Shield module. It is a trusted code implementing functionalities that applications and library OS need. It includes a memory allocator and a region manager, a private file system, which is implemented on top of an encrypted and integrity-protected virtual hard disk. A scheduler as a host is not trusted to schedule threads. An exception handler for handling exceptions such as page faults and emulating some instructions such as CPU ID. The Shield module also has a general policy of sanity checking of all the untrusted inputs that come from the outside the enclave. It checks the results returned from the system calls to the enclave. So if it detects something wrong, the application running in enclave will panic and terminate the process. For evaluation, Ivan is implemented and tested using the SGX emulator provided by Intel. With parameters for modeling SGX performance, which is more than 10K cycles for SGX instructions and 30% slower RAM access, execution using SGX runs slower than native execution in a virtual machine from 35% to 65%. However, this trade-off is worth achieving security in adversarial cloud environments. In conclusion, cloud services have been becoming prevalent because of their advantages, but there are also security risks. This paper proposed and implemented Haven, which is a system that allows shielded execution of unmodified server applications in an untrusted cloud host. Haven is progress in building a true utility computing model for the cloud, where the utility provides resources, for example, CPU core, storage, networking, but has no access to users' data. This is the end of my presentation. Thank you for your attention.